Hi everybody, my name is Martin Pratchett. I'm the Engineering Practice Manager here at Engineering New Zealand, and this is the 8th in the Lessons to be Learned webinar series. Today we have the Sustainability Society on to talk about some lessons that we've learned in the past from engineering mistakes, and it's going to be run by Monique Cornish, who is the current chair of the society. And you'll be able to see the recording when it comes up on our website, and we will be putting up a case study that you can download there in a month or so as well. Thank you for your time, and Monique, I will hand over to you from here on.
Tēnā koutou katoa, ko Monique Cornish tuku ingoa. Lovely to be broadcasting to you from my bunker here in Tāmaki Makaurau. Wherever you are today, I hope you're warm and safe, and we're really looking forward to sharing some of our lessons with you. So we've been finding out a little about you in the polls that you've been answering, and it's my job to introduce our team. First of all, TSS, the Sustainability Society. We're a technical interest group of Engineering New Zealand. We represent not just engineers, but actually a really diverse group of practitioners across the built environment, including scientists, planners, policymakers, and researchers. We have, I think, almost all of those with us today as we take you through our little tour of some of the lessons you need to know to help Aotearoa respond to the climate crisis. My colleague Alan Brett will be sharing perspectives from the energy sector, followed by Warner Britton, who's going to talk about buildings and infrastructure. Stu Farron is going to touch on water, followed by Cam, who'll be sharing some lessons from urban form and function. My job is to, I guess, set the scene a little. And I'll do that firstly by sharing with you exactly why this is a climate crisis. If we don't change what we refer to as business as usual, by the time our kids are coming to the end of their lives, temperatures will be significantly warmer. We're already experiencing sea level rise, but that could extend to a metre by 2060, followed, of course, by extreme weather. Again, something we see already, whether it's the storms up here in Auckland that took out our power network, the floods down in North Canterbury most recently that are still impacting farmers' livelihoods and our food security. And of course, drought too in North Canterbury and up north in Taitokoro, again, impacting livelihoods of individuals, communities, and the security of Aotearoa. With warmer temperatures comes bushfire risk, something we don't think of a lot in New Zealand, but again, Otago, North Canterbury, these are risks that we're seeing realised today, not just when we think of 2060 or 2090. You might have heard, I guess, the Paris targets where we talk about a 1.5 degree world or a 2 degree world. Those are aspirational targets. We're all going to have to lean in order to change how we do business to meet those targets. And I guess I want to reinforce for you that even if we globally are successful at limiting warming to that sort of 1 to 2 degree mark, the impacts that you can see on your screen will still happen. Climate change, to some extent, is locked in. The question is, how much? And we can absolutely turn the ship around. If we pop to the next slide, she says, hoping it's working, there we go. So we all have a part to play in this thing called mitigation. If you look at the wheel to the left there that shows our national carbon footprint, you can see engineers and I guess those of us who are engineering aligned in the planning fraternity scientific community and research, you can see us throughout that wheel, whether it's working in agricultural services sectors, designing irrigation arrays, working in industrial processing, mechanical engineering, waste management, energy in the built environment, which we'll focus on a bit today. There are engineers everywhere in that system, both on the ground and, of course, directing businesses, policy, in central and local government to help respond. So we have a very important role to play as a community of practice as we figure out how to mitigate and then ultimately live with those impacts of climate change that will still happen, whether we like it or not. Last but not least, I want to share with you a little bit of that policy context. There's a big shift in climate policy emerging, if you like. We're not too many weeks away, hopefully, of beginning to consult on the next big piece of work from central government, that being the emissions reduction plan, which will respond to the advice provided by He Pōʻarangi, the Climate Change Commission, earlier this year. That will set in place, confirm our response to the emission targets and budgets of He Pōʻarangi, and lay out policy for the next 15 years to meet those targets, hopefully. We also have work underway in the form of adaptation. The National Climate Change Adaptation Plan will be consulted on early in 2022, which is that second piece of the puzzle. How do we respond to the impacts while we transition to a low carbon economy? So I feel like government is beginning to do its part, and now the challenge is with us as practitioners. What is it that you can do every day to begin to integrate climate risk and carbon mitigation into your practice, your business, or your community? Now, the team have got thoughts as practitioners, as I said, focusing on energy, water, buildings, transport and urban form, to share what's gone well, to inspire you with some tips and tricks that you might be able to adapt or integrate into your practice. And please do, you've already had your fingers exercised, telling us a bit about yourself and your context. Please do use the chat function the Q&A function to start asking your questions of the panelists. Hopefully we'll leave plenty of time to address as many as we can. I will hand over to Alan Brent and to share your energy perspectives. Kia ora.
Kia ora koutou, and thanks for making the time available to join us here today. There are important lessons to be learned out of the climate in terms of climate change adaptation and mitigation, as Monika has discussed. And the wheel that she showed there, apart from the agriculture, which is probably our biggest challenge in the country, energy is the second most, just being over 40% of our carbon footprint. So what do we do in that space, and what have we learned so far? So just on a higher level, I guess we all know that the current status quo is that we have largely, there's been quite a bit of changes over the last decade or so, but largely we still have a very centralized system. Yes, we're fortunate from an electricity perspective that we are reasonably green in New Zealand, but from an overall primary energy perspective, we have a long way to go. And it's really the way the energy sector works is sort of a one-way direction, right? And we now know that we have to implement these 3Ds, right, in the energy sector. It's decentralize, decarbonize, and digitalize. So we have smarter systems, smarter ways of doing this. We have prosumers, right? So we don't have consumers only; they can be active participants in the energy sector now as well. And so, how do we get this transition from the status quo to this future more resilient and low carbon energy system? So, apart from the 3Ds, decarbonize, decentralize, digitalize, what more? And those pictures I took out of a talk from Amory Levins. It's now a decade old. So Amory is with the Rocky Mountain Institute in Colorado, and he's been advocating this transition in the energy sector since the early 70s. And he has showed that this won't come at a cost to our economy. Indeed, there are major opportunities for us. But the issue that he raises is there's new technology coming. We as engineers understand some of these upcoming technologies, and they're going to disrupt. And the one task that we need to deal with is how do we harmonize that disruption? We're going to have to bring a whole lot of different technologies together, and I'll get to that in a little bit way. We're going to have to integrate these technologies, and it's our tasks as engineers, as planners, as scientists to harmonize these disruptive technologies. Another issue that we as engineers, we on the technical front, we're techno-optimists. We believe that technology can do a lot apart from behavioral changes, but we have to manage those behavioral changes. Because we still have a lot of resistance to some of this technology. That's just human nature, right? So how do we deal with behavioral change over time? And our systems need to be resilient enough to deal with behaviors and expectations of different stakeholders within the energy system. Primarily by many of the stakeholders, as I said, it's seen as it's challenging, and they might not be willing for this transition. So one of the key tasks that we have in the energy community is to inform stakeholders. Just before this webinar, we had a whole workshop talking about agri-PV as an example. So this is where we can go and put large-scale solar PV systems onto farms while still having farming operations. But we've seen in other parts of the world, again, there's a resistance. It's just now introducing an industrial system on farming land. And yeah, so we have a big task as engineers to actually inform stakeholders about what these technologies mean and how it's going to play out in our communities, in our society, and in our economy. And so all of this actually means that we need a system integration. And so we need to understand, always keep in mind that our technology is only a subcomponent of certain institutions that make those technologies happen. That's part of the economy, and the economy is only a part of society. There's all kinds of other cultural issues, and all of that is embedded within nature. And on the left-hand side there, I'm just emphasizing again, yes, it's technology, and there's events occurring because of technology, or the technology is responding to certain events, like climate adaptation, but there's also behaviors of people, because at the end of the day, we need to have a people and ecosystem-centric view around how we're doing things. And that just means that we need this systems perspective. Very importantly, what we've learned in the past when we brought in new technologies, and an example there would be things like microgrids in more remote communities. The mistake that we've often made is that we just have this top-down approach, sitting either in our ivory towers here in academia, or sitting in government institutions, enforcing certain things from the top down. And that has really led to many failures in the past, because very often we do not have this bottom-up approach where we really actively engage with stakeholders up front, understand their needs, and how certain technologies that we're going to introduce from energy. I've always said that people don't necessarily want the energy, they want the services that come from energy. And so we really need to understand that in a more comprehensive manner, so that we can have this sort of strategic, equitable interventions. Because we can have this transition, but it needs to be a just transition, right? We can't leave people behind. And so for that, we need, I think, as engineers, we very often, in systems engineering, we always say that we need to do a needs requirement analysis up front, but very often we don't spend the time and the effort in that first phase. We simply go into a project, right? And that can often lead to failures. Okay, and we need to think about appropriate systems. I mentioned the agri-PV as an example. We can't look at our sector that we work on in isolation. There's value addition across different sectors. So, yeah, in the case of agri-PV, there's value addition of the land, there's value addition of the water, and energy is only a component of this overarching farming communities or more remote communities. And so, yeah, the lesson there is just working across sectors, thinking about value across sectors, and not just having this very narrow focus in our line of work. So to end off on the energy sector here is, yeah, the 4 Ds are happening. Apart from the 3 Ds, there's the 4th D, and that's disruption. And we're seeing it, this is an example of a microgrid in the Brooklyn neighborhood in New York, where people they've set up their own system, they've set up their own markets, they're trading electricity with one another. So the main lessons that I feel is that we as engineers, we need to be adaptive to this disruption. And yeah, that disruption is happening pretty quickly, right? So being adaptive is pretty important. We need to have this transdisciplinary approach. What we mean by that is we don't develop solutions for the people, we develop solutions with the people. Again, we need to have a systems focus. We need to think about how we influence behaviors, how we inform stakeholders, work with those stakeholders, and yeah, just think outside of our sectors. Thank you, Monique.
Thanks, Alan. Kia ora koutou, ko Warner Brunton ho. I'm going to be talking a bit about climate action for buildings based on my experience. And this is a bit of a taster for another session we'll be running in November, which is focusing over an hour and a half with a workshop discussion at the end on the built environment sector. So I guess following on from some of the words that Alan shared around systems thinking, one of the things that I've learned in my professional practice and focusing on sustainability in the built environment is that buildings are in fact systems. They're not just objects. I think that it's true to say that as professionals, whether we be structural engineers, building services engineers, civil engineers, scientists, architects, whatever it may be, that it's true to say that we all have a part to play in producing what is a piece of vertical or horizontal infrastructure. But all of those contributions that we make generate a system in itself, and those buildings and the systems are part of broader systems that create cities and communities. And it's really important, therefore, to think about what place buildings and built infrastructure plays in its contribution to not only the environment, and Monique has already set out the reasons why we should be thinking about the impact on the environment, our social fabric, governance and economic impacts, and more broadly our society and cultural heritage. So I think one of the first things we need to remind ourselves is we might not be just the engineer doing a little piece in our little silo. We're actually making a contribution to what is a much larger system. So what we've seen over many years, and this is attributable to Bill Reid from Regenesis, is that old school sustainability, or OG sustainability, is really just simply less bad. If you look at the bottom left-hand corner of this diagram, is conventional thinking has tended traditionally to result in buildings, particularly in the 70s, that consumed a lot more energy. But with the advent of green and sustainable building movement over the last 20 years or so, a lot of focus has been put on making buildings less bad rather than what is truly sustainable outcomes for the built environment and the infrastructure that goes with it. So the main move or the main shift in response to our pathway to net zero carbon and action on climate change and 1.5 degrees has turned towards what is regenerative design and focus on living systems or net positive projects, truly sustainable projects which contribute rather than draw on the natural capital that we find around ourselves, the resources that we consume, but also contributing positively to human and social capital. So we need to start thinking more about how buildings contribute positively to the environment rather than continuing to draw down the finite resources that we have to use. And of course that extends to subjects like circular economy and what have you. So just thinking about how we go about implementing strategies for these sorts of projects, it's really important to recognize that the strategy is what takes you to the outcomes. And there are tools out there, green building tools, that help take you on a journey for sustainability, and they provide a framework by which people can have a common language and third-party certification, all those kind of things. But often with the tools, not one size doesn't always fit all. So we need to make sure that we marry the use of those tools with a clear strategy to deliver sustainability outcomes that are measurable with specific targets. We've seen on projects that haven't been clear about delivering targets, they haven't been able to achieve the objectives or the outcomes you would hope. So if you don't have a target, say on energy efficiency, and you don't track that target, then you can't hope to achieve that target. Green is the new black. For a long time, green buildings have been the new black. They have been in vogue, but now we're finding black is the new black. And what I mean by that is this focus on carbon reduction, both embodied carbon and operational carbon in the built environment is really to the fore, and we've seen that signaled through consultation, Building for Climate Change, and Ministry of Business, Innovation and Employment are doing a lot of work on that, and the Climate Change Commission has signaled a lot of work in this space as well. What we're seeing is that as we drive deeper on operational carbon reduction, that is implementing energy efficiency through the whole demand chain or supply chain, depending on which way you want to look at it, that the impact of embodied carbon is becoming more and more prevalent. So we're seeing a lot of projects starting to look at materiality and design that looks to sequester carbon rather than lock in more carbon through traditional construction technologies. So you're seeing a lot more use of mass timber or hybrid timber steel structures to reduce the embodied carbon of those buildings. And of course, performance outcomes and innovation drive reduction. So how do we achieve net zero carbon? Well, there's a pretty well-worn path now, even this early, and really reinforcing that notion that it's the measurable outcomes that count, is that we need to minimize both embodied carbon and operational carbon. And once we've done that, we need to look at opportunities to use energy more efficiently and use renewable sources of energy. We then need to measure that performance, verify the outcomes, and improve. So this is, as we'll be familiar as engineers and scientists, plan, do, improve, repeat. And then, of course, at the end of all of that, look for offsets. But net zero carbon is taking us on that pathway to avoid offsets. So the next thing I would say is to turn those declarations into actions. What we saw in the last couple of years is a lot of peak industry bodies committing to this notion of the climate and biodiversity emergency. And certainly it is there. But what I'm seeing in professional practice is that individuals within these professional bodies are actually not living up to the commitment that I think their organisations would hope for or society might expect. And so the opportunity for us as engineers and professionals is to act in a way which is consistent with the declaration that we're making. So focus on those meaningful outcomes. Remember that the decisions that we make today have lasting consequences. Use innovation to change the way we do things and look forward, not backwards. Finally, what I would say to wrap this all up is that, as Monique has said, we need urgent action on climate resilience and adaptation now. We need to show leadership in our professional practice and as a fraternity of engineers in practice. We need to aggressively drive down embodied and operational carbon. We need to take an integrated design approach, thinking about systems rather than silos. Regenerative design and systems thinking will help us target those net positive outcomes. Green rating systems are important, but people and performance focus delivers the required outcomes if we take a whole of systems approach, quadruple bottom line. And finally, thinking about humanistic outcomes. We are, of course, creating infrastructure, including buildings and horizontal infrastructure for people, but we need to do that in a responsible way. So again, for too long, we've been part of the problem. Now there's the opportunity for us to be part of the solution. Kia ora.
Kia ora koutou. Ko Stu Wharantaho. Thank you very much for that, Warner. And if everyone could just remember Warner's last messages, they were very pertinent and apply to what I'll be talking about today as well. So I'm going to take you on a quick whirlwind run through, I guess, of some of the lessons that I've learned from the last 15 years working in the area of urban water and how we can integrate water into the environmental outcomes within our built cities and towns. It's a bit of I guess a showcase of some of the challenges that have occurred that have, I think, prevented New Zealand adapting to the changing climate and the environmental outcomes that result from that. So the first real lesson is that our communities have lost their connections with the waterways. These waterways were once precious and taonga places that supported our cities when they were first developed, but those connections have been severed. Initially, waterways were seen as a convenient way to create roads and to create areas for our towns and cities to develop. And this photo here and the next few photos are all of Nauranga Gorge in Wellington, which some of you will know quite well. So we initially viewed these as a resource to work alongside, and we lost the fact that they had natural processes. So for a period, we lived alongside ecosystem services, and we were able to I guess, get mahinga kai and live within a natural system. But progressively we grew and we lost those connections until we're at today. And again, this is the same aspect as the first photo of Nauranga Gorge, where we exist in an anthropogenic world where our freshwater natural systems and the ecosystem services that they once provided are now relegated to subterranean pipe networks and really used as a resource to take waters away. Those of us in the engineering and science world sort of understand that, but it's become clear to me that the communities within which we try and work are often unable to comprehend that or necessarily take it on board. And so where we once had thriving waterways, we now have a myriad of pipe networks. And today we have around about 85% of New Zealand's population lives within an area with around about 1% of our freshwater streams left in the urban environment. And gone are those mahinga kai and those cultural connections with the waterways that once existed. The second lesson really is that often the solutions are very complex. Warner touched on the interdisciplinary need with regards to building, and this diagram that I've got here is purely looking at the water elements of this building. So this isn't touching on the materiality or the energy demands within that building. This is purely three waters if you're trying to manage that in a holistic way. So there is complexity, which requires an interdisciplinary approach to work through, and that in itself is a challenge. And often the solutions seem more complex than they are. So as we talk about nature-based solutions and ways to manage urban water, such as constructed wetlands or rain gardens and things, we need to understand that there's a whole layer of complexity in terms of the biological and the chemical processes that underpin those. And at the same time, as professionals, we often lurch towards language and technical jargon. Whilst we understand this and it can, it satisfies that we're talking to the subject, often the stakeholders, be they client stakeholders, be they community members, be they mana whenua, the technical jargon that we use to describe the work that we do is often an isolating factor that has been shown through research to make the transition difficult and more of a challenge than it needs to be. And then finally, there's the old curse of the RMA process. It's no surprise to many people that a lot of the work that we do involves a very tortuous pass through a very litigious process. Well founded in the 90s when it was drafted, it's really become a challenge in many fronts and really an exercise in really drilling down into details that distract from the main issues that we're trying to deal with. And so out of all of these challenges, I think now is a really important time for us to reflect on those challenges and look towards how we can actually overcome those. And as we confront the issues with the changing climate and the social and environmental impacts that brings, we need to look for solutions. So the first of these that I present, I guess, is around embracing innovation. We live in a time, a very data-rich time, a time where we're all connected through our phones, and we understand the errors and the challenges that came before us. And so through embracing innovation, and the example here is around smart rainwater tanks that provide lot-scale flood detention as well as harvesting water for reuse within a house that's all controlled through the internet, and self-purging tanks and things is a reality that we can bring to the local market to achieve multiple benefits around flood control, but also environmental management and resilience. And the next one is around moving towards more distributed systems. This is a distributed wastewater system in a highly urbanized area, servicing 3 large multi-story commercial and residential buildings. This is managing our waste in a way that connects the community with what is going on and actually values the nutrients and the water as a resource that can be reused, similar to the whole concept around a circular economy. And the next is around depaving. We need to introduce more pervious surfaces into our city, and these can be done through widespread use of things such as green roofs that also support the provision of biodiversity, biophilia, as well as retaining water within the landscape. So this picture here is a high density urban development where in an aerial perspective, the imperviousness of it is close to 0. And we also need to embrace the flooding that's coming. For too long, we've tried to create cities which are protected from flooding rather than embracing it within our landscape. And that's about designing spaces that don't exclude flooding, but in these rainfall events that come, they actually bring it into the community and connect us with what's going on in the wider hydrological cycle, and at the same time enable these spaces to be used at other times for other purposes. And this is an example here from Copenhagen in Denmark, where highly used active spaces are designed as flood retention basins. So hopefully through taking this more holistic and well integrated thinking across multiple disciplines, we can evolve to a city it's towns and cities where we can learn to once again love our taonga species that exist within our waterways. Thank you very much.
Thanks, Stu. Kia ora koutou. No te whenua o te moemoe aho kei Tāmaki Makaurau Takakoinga. Ko Cam Tokawengoa. So my name's Cam Perkins. I'm joining you today from Tāmaki Makaurau, Auckland. But I'm originally from Brisbane. I'm over from the West Island and call myself a recovering Australian. So thank you for having me. So I'm here to talk to you today about movement and place, aka transport in cities, but I'm not from the transport world. So why, you ask, would someone calling themselves an urban pirate be talking about transport lessons to a group of engineers? And the reason is that I design destinations. I've spent 20 years working through the Middle East, the UK, Northern Africa and the Pacific, so delivering private and public destinations. And I've figured out what makes great places work, and I know how to keep people coming back. So I've given up the high carbon habit of international tourism, and these days have turned to focus on cities as destinations. And just as Stu has shown, there are many types of public infrastructure that are also destinations for people. And we need to be looking at how we manage our resources in cities in a much better way, because we're facing a bit of a challenge. So transportation underpins our society. It connects people, cities, economies, and it fosters growth and employment. Yet, as millions of us move within and between cities and countries every single day, transport is the fastest growing source of greenhouse gas emissions in Aotearoa, and it's all by design. So one of the biggest lessons of the pandemic is that we've also seen significant compliance with travel restrictions, with people changing their behaviour that Alan was talking about in the start. So we know that disruption works. So how can we make it work for us? How might we use disruption in a way that helps us to achieve our goals of mode shift and transport emissions reductions? Because as we know, climate change is coming and the emissions reduction plan is coming, and that's going to be requiring quite a bit of us. So I fundamentally believe that if we can change cities, we can change the world. Did you know that transport is a ubiquitous unlocker of cities? Great movement unlocks great place. And when we have more great places, we tend to move about less. Less reliance on things like internal combustion engines and private motor vehicles. So welcome to the future of the transport profession, where you are all agents of change. And I'm talking to you today about how to get past the dreaded paralysis by analysis. So as agents of change, we want to know how to turn our shiny strategies and frameworks that Warner was talking about into real action. So my hunch is that the secret lies in human behavior. So let's get better at understanding humans. People feel change. Change is visceral, which makes it really hard to talk about change. So why just talk about it? We all need to get better at exploring change with real life humans. So we all know that when we're exploring change in cities, we tend to hear from those with enough time, enough energy and passion. So how do we hear from those who are less heard? A pilot project demonstrates change and allows people to talk about it while they're also in it. Pilot projects allow people to see, touch, feel, and discuss the change. And here's the real kicker. People start developing new habits and they demonstrate social proof to each other. This is all great evidence for things like your business cases, because you can gather data in a real world environment instead of just using models and reckons. So, just like the Eastern Viaduct in Auckland's waterfront in 2017, this was a place for 50 car parks. By 2018, a destination created through a collaborative process with youth. A car park is now a destination for people. And with a tactical vision, it now has a master plan and it has funding to go to a permanently built place for people. So imagine the space that you can unlock in your city relatively quickly. So we need to experiment with people. We need to learn and scale with our communities for impact. So what I showed you was a car park. What about a street? Many of you will know High Street in the middle of Auckland. So here's some quick stats. It had 42 on-street car parks over about 300 metres, had 18 times the number of people walking compared to the number of people in cars. And despite many attempts at change, nothing had ever changed. So my first question to the people of the street was, what is it about change on High Street? And the resounding response was, of course, change. No one could agree on how it would work. And they weren't going to put up with yet another consultation that got them nowhere, or even worse, got them somewhere they didn't want to be. So quite simply, they didn't trust the change process. So we waved our pilot project wand over High Street, and here's how it turned out. So we've had 97% support to remove on-street parking. We got it done inside a year for 5% of the traditional street renewals cost. This approach has now been baked into council's street renewals process, and that's real system change. So the real success here was how it felt. One retailer said to me at a workshop, "We've never been trusted to all be in a room together." So participatory partnerships work. We can build the future together with our communities in a truly collaborative way. It's a really great skill for those of us in the engineering, science, the urban change fields to have. So if you're not satisfied with just a street, what about a pilot program for a whole country? This is Waka Kotahi, New Zealand Transport Agency's Innovating Streets program, something I've been working on for a while now. I've been running the national community of practice. So it's building the learning and development program that delivers capability and capacity in rapid urban transformation. We've worked across 33 councils, delivered around 70 projects in 1 year, and that's doubled the yearly average delivery of walking and cycling projects in the country. So we're now working on scaling that up for even greater impact. And we're starting to take the practice of pilot projects into business as usual. And that's real change. So the big message here, don't let your strategies and frameworks be shelved because of the dreaded paralysis by analysis. Treat change like a great adventure. Design your adventure together. Prepare for the ride. Take the first step. Just get started. So one more thing. Just like the legendary Brian Eno says, think like a gardener. Design beginnings and not endings. And that's all from me. Kia ora koutou katoa. Have a wonderful day. Over to you, Monique.
Kia ora, Cam. Thank you, everyone, for sharing your insights. And it always makes me glad to see Brian Eno at the end of a presentation, an engineering presentation. Well done, Cam. Could I actually see, we'll see if technology will allow to invite all of our speakers back on screen in a panel format. And if we start to lag, I trust someone will let us know in the chat and we can turn our cameras off. Seems like, I feel like mine's struggling already, so we'll see how we go. Do we have any questions from the audience? You're all a bit silent. There's been a huge amount of information and aspiration thrown out. While you formulate your questions, I've got a couple that came to mind for me. The first question could actually be for any or all of our panelists. There was a theme that that I heard around behaviour change. Not so much what we build, how we build, or even maybe where we build, but how we already use the assets we have. Cam, that was really the work of Living Streets Aotearoa is a kind of a massive scale, or beginning to upscale those principles. He Po'arangi in their final advice made it very clear that behaviour change is important when we think about our water assets, our energy grid. We know that reducing demand will stop the need to build, reduce the need for more carbon in those embodied emissions, and allow us time to plan the future built environment we want in the context of a changing climate. Now, my question, all of this is great, but what's an engineer's role in facilitating that behaviour change? Not too many engineers end up sitting where you're sitting, Cam. So thinking more of our project engineers, or perhaps working within a design team. It could be mech-eng, it could be civils. What's your message to those practitioners in terms of how they can integrate the principles of behaviour change into their projects? Cam,
I'm happy to take that if that's directed at me. Yep. Thank you.
I think everyone, but yeah.
Yeah. Kia ora, Monique. Thanks. That's it's a really wonderful question, right? And the key word that you used there was, how do we facilitate this? as in how do we make a safe space for these sorts of ways for people to be talking about the challenges of change. Essentially, these are human problems that we're dealing with. So humans have the solutions inherently within them. We need to be comfortable with talking and cultivating conflict. We need to be comfortable with setting up safe spaces that allow people to explore these new ways of doing things. So, a project engineer, or someone who's working in investment in a business case sense, put the investment, make the space for the people who can help you from a behavioural perspective, from a collaboration, a community work perspective. Make the space for those people to shine in your project, and it will make it infinitely easier for you to be moving down that behaviour change spectrum.
Thanks, Cam. I might ask a question on the 3Ds or 4Ds. Again, we've got another music reference here. Not the 3Ds as in the band, but the 3Ds, which includes digitisation. Alan, could you expand a little bit on the D of digitisation in terms of how that will support us to reduce our carbon footprint?
Yeah. I think it links, well, Stu had a slide there showing that we are in a data-intensive phase of our society. We're all connected. And what we can do, what we now are doing with distributed energy systems is, as I said, we are dealing with it in the smarter ways. I'll give one example. At the moment, one company, I'm not going to use any names here, has over 5,000 batteries distributed across New Zealand in households. And because we can communicate with those batteries, means that we can possibly from a centralized perspective, we can start managing those batteries. And that means what we've seen down in Wanaka as an example is that we don't need to upgrade distribution systems or lines because we have all these batteries that we can manage in a more smart and effective way. But that means that we need to be able to communicate with those batteries. And this is where we're moving towards when we go to decentralized. And this is what we mean by digitalized. It's not about electrons flowing in terms of the power, but it's also about communicating effectively between the different parties in the energy system.
Thanks, Alan. Stu, Rob's on the line. He's wondering about, I feel like this is a governance and government question, but how do we change, I guess, the system so we set up the ability to let the water in? Those last images that you showed of Europe where letting the water in is really standard. And as you said, a really beautiful way to connect to nature as well as control floods. There's a lot of barriers to that in Aotearoa. Do you want to talk to perhaps not so much the barriers, but what you think some of the enablers might be moving forward?
Yeah, cheers, Rob, and thanks, Monique. In terms of enablers, I think that communities just need to understand that when these events do occur, there will be disruption. When we have a 10-year flood, a 50-year flood, or a 100-year flood, it's not business as usual. There will be water in the landscape, and things like transport may be affected. Cities like Copenhagen and Denmark are lowering streets and designing streets as part of the stormwater network to actually flood and become unpassable during certain flood events. Whereas in New Zealand at the moment, that would be unheard of, at a local council and at an NZTA level. And so I think that's the biggest barrier to overcome, is recognizing that disruption will occur. But then I think also just embracing that innovation and understanding that we can have dual systems that might capture water to use in the ordinary times, but you can now, with better forecasting and things, we can purge some of those systems and actually then have them empty when storms arise, rather than having to have redundant infrastructure that sits there empty all the time waiting for the storm event. So it's a bit of a combination, I think. But the barriers really are more psychological than anything physical. And they just need to be, I guess, overcome.
audience members in central and local government. So maybe we'll turn that challenge or to support reducing some of those barriers to them as well. Hey, Alan, there's a question here. I've lost it from Mitty about nuclear energy, and it's a question that there was quite a bit of conversation about it when Hupuarangi, the Climate Change Commission, released their report. It's also it's a dirty two-letter word in Aotearoa, but I guess one of the principles that I stand behind is the idea that all ideas have to be evaluated equally. Otherwise, we just get the status quo. So I'm going to ask Mitty's question of you to what is there a role for nuclear energy? And perhaps you might like to expand your answer a little bit to think about some of those less common forms of energy that we have in New Zealand, not just nuclear, but distributed energy. Perhaps tidal could also be in the thinking. But yeah, take us through how we can meet our future energy needs.
Yeah, so just on that, if you're not following the energy space, that we're going to need between 2 and 3 times the amount of electricity if we're going to start electrifying transportation and industry and so on over the next 3 decades. So yeah, looking at these different options become really important. Nuclear, there's been quite a bit of development around things like pebble beds and so on that make very stable waste and less risky waste. So there's been a lot of technology developments on that space. Personal feeling, and many others out there, is why would one want to invest in a technology that no private investor will support? So, I mean, the problem with nuclear around the world, it's always backed by public money, taxpayers' money. And that's why we're shying away from that. So forget about all the other environmental discussions of what do we do with waste for the next few hundred or few centuries or even longer. It's simply that. A lot of us feel uncomfortable with getting taxpayers to support some kind of technology, and that is the reality of nuclear. Furthermore, I think there's many other options for us. At the moment, you might be aware that we have the NZ battery project going on, which is primarily looking at Onslow as enormous battery potential. But many people are saying we don't even need that. Just on the storage side of things, I'll give you an example of Chile at the moment. Chile is investing gigawatts into liquid air storage. And why storage is really important is what we want to get away with is to have this demand. Morning peaks, evening peaks, etc. We want to flatten that out, and then you don't need a lot more generation if you have this distributed storage. So liquid air, hydrogen has been mentioned. There's a bit of a hot potato that's been discussed, but that's certainly an option. We have underground storage options in New Zealand for that. And then just, as I said, normal batteries. If we just start building megawatt scale batteries around the country, not only at small scale houses, but we're ramping it up into the lines companies and so on, we can do a lot better in terms of managing the overall system. Generation, I mentioned agri-PV earlier on. If we can effectively introduce that into and people very often shy away from solar in New Zealand, and I always say, you know, Freiburg is the solar capital of Europe, and Freiburg is further from the equator than Invercargill. So the entire New Zealand is, in fact, better or in that case. And that resource, again, is distributed and we can manage it more effectively. Yes, there are technologies that we've looked at, like tidal, and for instance, the Cook Strait down where we are is a great potential resource. It's just a cost issue. And there are other low-hanging options for us. We certainly feel that with the resources that we have around wind, solar, biomass, and given the projections that we have in terms of what we need to deliver in the next 3 decades, as I've said, together with all these different storage options, we can do it without any of these high risk for our potential future, or potential high risk for our future.
Other future energy futures as well. I'm conscious that we are drawing up on 1 o'clock. Thank you to those of you who've given up your lunchtime to join us. Before we go, I'm going to twist Greg's question around a little and ask each of our presenters to give us one last thought of what practitioners can do, and keeping in mind the question around perhaps some smaller firms who don't have the internal capability and capacity of a dedicated sustainability team. Where can they go for help? I mean, I want to say TSS, but I'll say that and then let you guys put your thoughts forward of where people can go to for a bit more information apart from us. Cam, I'll start with you.
I think industry groups are a great way to start. Community groups are a great way to start. Just to be having conversations in like the barbecue chats around the sorts of things that we need to change. Use your understanding and knowledge of the things that you're keen to work in, and share that story. Share how hard it might be for you or how successful.
I have to agree.
Oh, sorry, you go, Alan.
No. Just want to say I agree with Karen. It's all about initiating conversations, and just get out of our offices or out of our bedrooms or wherever we are these days, and just engage with people out there, and just actively. I mean, it made a big difference when I was a young engineer, being exposed to different disciplines and just what the social scientists like call a different lens of looking at the world. It really opened up our eyes, right? So, but you need to be active to go out there and seek that engagement. Yes, there's TSS and there are other networks that you can join and have those type of convos. But yeah.
Yeah, okay. I'd emphasise just learn how to collaborate. There's some really great practitioners across all of these areas out there. And when you connect with them, you can form really powerful teams. So I guess learn your limitations and learn what you do well and what other people do well, and then really, really encourage clients that that the right input at the right time is key. In the water space, too often we're brought in at the 11th hour. There might have even been questions already raised through a resource consent. It's like, shit, we better do something about the water. It's too late by then. So it's about the right team at the right time, and just getting clients to understand that works in their favour. And it's good fun.
Probably 3 quick things. First thing, we've got a series coming up in October, November, December. The TSS is running, where we will be workshopping climate change resilience, risk resilience, and transition. And so there's a great opportunity there to engage in that series, which will be being promoted through Engineering New Zealand's network very, very shortly. The second thing I would say is that we, from my point of view, I guess I came to the conclusion some time ago that there should be no intellectual property when it comes to sustainability. That when the green building movement in particular became popular maybe 20 years ago or so, everybody was seeing this as a point of difference and an opportunity to, I guess, make more money and differentiate yourself from your competitors. That is long past us. We need to be working together collaboratively to deliver outcomes. So reach out to practitioners that you are seeing are doing the hard mahi, and learn from them. And equally, those of us who are already working in this area, get out and share your knowledge and lift everybody up to go forward. And I guess that's one of the reasons why we are sharing our experiences here today, is because we want to share what works and what doesn't, and where the great opportunities are. So engage. Collaboration is always difficult, particularly for the small practices, but reach out through your through Engineering New Zealand and through other networks like TSS, Green Building Council, Infrastructure Sustainability Council, government engagement. There's lots of different channels that you can get into. Just participate.